Hi, so this video is going to be about triggers in nbphysics. If you don't know what nbphysics is, it's a physics engine that I made in GameMaker Studio. It's free and it's available to download on my GitHub here. For these tutorials, the code is also available to download on my GitHub. And I'm using the same repository for all of these tutorials. So if you want to download code for a specific tutorial, you'd go to, normally you would download code here with download zip, but you can go to the commits, choose which commit. In this case, if you are watching the force generator video, you go to force generators, browse files, and you download the zip there, which would download all the code that was made at the end of that video. And for these videos, as well as the physics engine itself, I'm using the long-term stable version of GameMaker. So that's here. Okay, so this will be the last video explaining the different parts of the physics engine. The first one we sort of got used to the, I guess, terminology and how to set up the engine with physics worlds and rigid bodies. The second one was about force generators. How do you apply forces to rigid bodies? And the previous video was about contact generators. How do these bodies interact when they collide with each other? And now with triggers, these are how essentially they're like collisions are with the contact generators, except they're way simpler. Where a trigger essentially just detects when a rigid body enters and exits the trigger itself. It's if you used Unity before, I sort of designed it similarly to that in terms of like how to use it. So triggers themselves are very similar to rigid bodies in their variables as well. They have a shape and an orientation as well as some uh, some collision bitmask stuff. So we can see that here with the rigid body. But as you can see, the rigid bodies have a lot more, and that's because of all the physics that's applied to rigid bodies, right? All the damping that's happening, the bounciness that is applied when a collision occurs. So triggers don't function like that. They're way simpler, and they're basically just collision detectors essentially as well. So rigid bodies, they also have this is the important part as well. They have trigger generators. So depending on whether or not this rigid body will detect the trigger at all is if they've created the trigger generator for it and they've added it to this array. And these are all the triggers that are currently being detected by the rigid body. They'd all be here, and they get updated every frame. And these are the important two functions that you would be changing between rigid bodies. What happens to the trigger? What happens to the rigid body when it enters a trigger and when it exits the trigger? So these are automatically called when that happens. You just have to change the logic that happens with it. And because the trigger is also passed into this function, that's where you would change the logic depending on what type of trigger you're walking into. So yeah, this is the code that's in the rigid bodies for the trigger specifically. And yeah, so for this video, we're going to be essentially, I'm going to show you how to use them. And if I think we need to, we can make our own custom one. So let's get started with seeing what we started off with from the previous video. So if I press play real quick. Okay, yeah, we have the previous one where we made our own floor generator. So we're going to probably remove the gravity and remove the rotation as well as remove the floor itself. So I'm going to start with that. So I'm going to go to the room here. So we have the two ball and player. So we can go to play real quick and we go to the draw. Or we can go to the create here. So we have movement, MB shape, image. All this stuff is fine. We're just going to remove the contact generator part and remove the floor part. and the gravity as well. And here's fine. This is just for moving. We can remove this part for rotation. Contact generator stuff here as well. We have to remove this because we don't have those anymore. And for drawing, we don't need to draw the floor because we don't have a floor. Okay, next is the ball. We will remove gravity as well. And I think that's it. Okay. Let's check real quick what happens. Alright, so the player can move around. Alright. So right now, this ball is a rigid body. So we can't treat it like a trigger right now. We'd have to change the object that it inherits from if you want to do that. If we go to the ball here, we can see that it inherits from the rigid body here. So we'd have to place a trigger here, but that would change. I think it would still be okay because this ball itself is, we wake it up and then we just change the shape. So yeah, I mean, I guess we could actually just change it. So I'm just gonna do that. Let's see what happens. Okay. Usually it would change. It wouldn't change the sprite, but let's make the sprite this one so we can see the difference. All right, and we set it into a circle as well, so it should be a circle. Oh, also, I think it would still be a outline as well. No, it's not. Okay. Okay, so right now it's a trigger. The ball is a trigger, and the player is a rigid body. So if you walk into it, you would think it would detect it, right? But nothing happens. For starters, similarly to the force generators and contact generators, you have to link them together. Like you have to subscribe to the trigger events. Otherwise, they're just in the physics world and nothing is actually happening. So that's what we'll start. Let's see. So let me think about this real quick. We can create. So the first thing you would want to do is if you want a rigid body to interact with triggers, you would use a trigger generator here. So we can go to the scripts here, go to the nbphysics, physics here, and trigger generators. So these are similarly to the force and contact, there's unique ones that you can make that inherit from the regular one, but this is the general interface for a trigger generator. So this gets called when, what's the return to rates? Oh yeah, so because what's a little unique about triggers is that you can be in multiple triggers at once. So the reason why this trigger, when these, okay, I guess to start off, what I can say, let's say we use the instance trigger generator, right? This detects instances or the regular rigid bodies uh, from detecting, or sorry, actually that's not true. These are as general as the contact instance generators. So it uses the shapes of all of the ones that are supported in the engine. In this case, for the instance trigger generator, it uses the rectangle, rotated rectangle, as well as the circle. So these are essentially very similar to the contact, the contact functions. I guess I can just show uh, the contact ones here, where they have a ones for the different shapes. The difference is for the contact generators, whenever a contact is detected, the contact information is filled out. Whereas, and this stuff is like things that you would have to calculate, like the normals, the penetration. So all these things can actually just be ignored in the trigger instance generators because you're not really applying a physics to the object when they interact with it. You just start detecting that it entered and that it exited. So, for example, here for the circle circle, if the radiuses are overlapping, then you just return, boom, return that it did happen. Okay, So, but yeah, in this one, this rigid body here can potentially be in multiple triggers, and that is why the trigger returns an array of all the different of all of the different triggers that this rigid body is touching. So yeah, that's just the whole explanation as to why this returns an array, because it returns an array of all the different triggers that it was in contact with. But yeah, it's similar. You pass in a rigid body, the physics world, and this DT in case you need to do some physics with it. If you are making your own trigger generator that inherits from the regular trigger generator, you can use that DT for your calculations. Okay, so that's an explanation for trigger generators. So to get started, to get this player to be detected by this, you would have to use the built-in instance trigger generator. So similarly to the other ones, you'd go into the player, you would go here and you would create the trigger generator. So you would go, and I would just call it TG for trigger generator, and then I'd call it instance is equal to a new trigger instant generator. This is the interface, the one that's not that has an empty function. This is the one that actually detects between instances. I call it instances, but they're basically just the supported shapes that are in the engine itself. Okay. And this is created, but it's not linked yet to this ball. I mean, it's not linked to the player. So we would go to the player this time with, we could do all rigid bodies. But in this case, it would only apply to the player because the player is the only rigid body in the room right now, because this is a trigger now instead, so it wouldn't actually apply to that. So we're going to go and use the nbp add trigger generator, and we're just going to go and pass in ourselves, and we're going to pass in the sorry, it's in the play, right? Wait, where did I actually create this? I'll create this in the draw. That is my bad. So this should be created in the create event. So in the create event, we're going to create this trigger generator instance, and we're going to add it to this rigid body, and there you go. So this rigid body is now able to interact with triggers. So we'll just display here. There you go. So as you can see, right when it interacts with it, it turns on and it turns off. And you can see as well, the bounding box is not being affected, so it's all based off of the shape of the rigid body. So yeah, these are like very lightweight compared to rigid bodies because they don't have any physics applied to them. But what is cool is, and why they're essentially in the engine, is so that you can apply forces and other things to any rigid bodies that are in the trigger. So that's what we're going to do next. We're going to use the OnTriggerEnter and OnTriggerExit functions so that physics can be applied to this body when it enters it. So let's just do something very simple here. I'm going to, just to detect, how to even use it, right? On enter, we'll just apply a force to this body on, we're going to apply a force to this body right when it enters it. So let's try that. So very simply, you would go right here, and because this player is a rigid body, if you go back to the rigid bodies here, it has a function already defined for it on trigger enter. So you just copy that. And in the player itself, because it inherits the event, we just have to rewrite it again. But instead, we're going to, we're going to actually do something to it. But just as a note, it's passing in the trigger. So say if we had multiple triggers, and they were different, like say, so this is a ball, then we can also make another, we can make another object here that would be like, I'm gonna just call it not ball. This is pretty bad, but whatever, it doesn't matter. We're gonna pass in not ball here. We're gonna go like this, create it, put it here. And instead of, because it's not a ball, we'll make it a different shape. A rectangle. Okay, whoops, I guess we're debugging. So there you go. If I go walk into this one, it works. And let's check this one out. It also works. So it works for all triggers. Another thing, if you only want to detect certain triggers, in this case, in this physics world, you can change it to only use a specific trigger here. So here we're using ONBP trigger. So any triggers that are children of this object will be detected. But if we say change this to a O ball, for this physics world, it'll only detect the ball itself. So we can go check here. Yeah, there you go. Okay. So you can have multiple different physics worlds running and having different simulations based off of like, yeah, you can do whatever you want with that, I guess. But yeah, that's a way to filter out what type of thing, along with using collision masks and stuff. So we'll put that back to the general one. So all triggers are affected. Okay, what was I gonna explain? It was gonna be the ball. Oh yeah, so we were gonna apply a thing here. So for example, say you have the ball and the not ball. If you wanted to do something specifically, if you touch the ball here, you would have to check for it here essentially. So I'm just gonna real quick just show that. So if ball print touched ball area. That sounds good. Whatever. Touch ball area. So we're gonna go if trigger dot object index is equal to O ball. If it's equal to O ball, then we're gonna show a debug message, and we're gonna go and just ball trigger touched or interacted with. All right. So if I walk into or move into this one, no message pops up. But then with this one, as you can see, interacted with here. And I might as well also show you, I guess I should copy the exit here just so it's on trigger exit would function the same, except it would only run when the rigid body leaves the actual when it leaves the area. So we can go and check that out as well, just so we can see. When you walk in, ball trigger interacted with, and then you walk out, ball trigger exited, and you can just keep doing that. And nothing happens with this one because we're ignoring this case where this trigger is not a ball. So, all right, so we're about to get to something that I'm going to show you. It's actually a bug in the engine, but I'm going to just roll with it here. If you want to apply, in this case, when you touch the ball area, I will just make a regular trigger now. If you just, when you interact with any trigger, if you want to apply a force to the rigid body here, that's what you can try doing here. So we can go nbp add force, and we're going to pass in ourselves because we're within the we're in the player right now. And we're going to make a force go to the right. So the right would be like we'll go 100. Actually, we'll go 1,000. And that's it. All right. And I guess just so we can see that it actually did run, we can just show a message here that said force added. Force added. Okay. And moment of truth. All right, nothing happened. Okay, so the message shows, right, force added. That essentially means that we ran through the function, but the force isn't actually being applied. So this is actually what I like found out when I was working on the engine while like trying to use it to make a game. So I actually updated it. I fixed that. That's something that you might notice. There might be bugs, but in some of these tutorials that I fix later, and I was going to show you how to update in this tutorial as well. Like, so if you can go to here, here nbphysics version 101. So changes from version 1.0. You can also download the original, I think, as well by going somewhere here. I don't even. Oh, here you go. This would be the original one, the one that in this tutorial we downloaded first. But in this version, we changed the order of trigger generators, and we also added some more demo folders. So yeah, this is actually one of the fixes that I did. So it actually isn't very hard to re-import this. So I'm gonna just do that. I'm gonna download this here. I'm gonna go to this version here and download the engine again. It's really small, 124 kilobytes. Okay, and I'm gonna re-import this engine or this package back to GameMaker. But before that, I'm gonna show you why this happens. So if we go to the physics world and if we go to the step, this is when all the physics runs. So there's just one function called run physics that happens, and after this function runs, we initialize the next frame. And these are two. This is really important order of operations here, because in theory, if you add any forces, well, actually, I'll show you what this does first, and what this one does as well. So run physics, it resets all the triggers. It applies the force generators to all the rigid bodies. It integrates all the objects. Integrating means basically moves it forward in time. That's the actual like time step that happens. This is where all of the actual physics happens here, where you do the forces, the acceleration, calculation, and you finally move the actual object. Let's see, where was I? I think it's really unorganized when let's go back here. Okay, after the integration step, here's where it is. Updating triggers. So when you update the triggers here, this is where the actual OnTriggerEnter and OnTriggerExits are even are run. So in this case, all the physics has already been applied to the rigid body. It already moved forward in time, and then it's checking for trigger like triggers, right? And if you add a force here, the physics already happened. Then collision resolution happens here, and then if we go to in the next frame, it clears all forces. So any forces that were added to the rigid body on trigger, enter, and exit, they're basically gonna get cleared. So that's a problem. Pretty easy fix though. I'll just show you what I did. Uh, you just have to move this before the integration step, and then that should be that's what I did. So and we can see that happening when we actually do the thing. So I'm gonna import. So I'm gonna go to Tools, Import Local Package. I'm gonna go to Downloads. I'm gonna go to nbphysics here, Open. And when you're re-importing, you can always just choose uh, whatever you want to re-import. And I'm gonna just re-import in this case general functions, because that's what I know is what I updated here. So yeah, so this re-import, we're only gonna be importing this one. We're going to replace and we're going to import. All right, and now when we go to run physics, as we can see, update triggers is now before apply force generators. So there you go. That's just something that's the cool thing about working with your own physics engine. Like, even though you find bugs, it's like an opportunity to to learn. So yeah. Okay, so now because we updated the engine, we can go back to just looking at what we did here. And yeah, it should definitely work. Or maybe not definitely, but we'll see. So now the force gets added to it. There you go. So now it's for customs, right when you enter it, a force is applied to the right. And not applied, oh, it's applied to this one as well, I forgot, because it just to both. So yeah, that's a way to use, to add custom forces on trigger enter and on trigger exit. We can do on trigger exit as well, just to show you. It's the same. Okay. So enter, nothing happens. When you exit, boom. Enter, nothing happens. Exit, boom. Enter, exit, enter, exit. Yep, okay, cool. All right, so yeah, that's how you use on trigger enter, on trigger exit. That's really all there is to it for triggers, I would say. Oh, actually, that's not it, but um, a way that I so the way that I did it in the demos, I didn't even import the demo, but there's a water pit, so I guess I can show you how you would do like maybe a pit of water, for example. And the cool thing about not even just making your own custom forces here, but using some of the pre-built stuff here, like to like add a force and then remove a force when you enter and exit, is a way to very cleanly add forces to objects. So I'm gonna basically make a pit of water as a trigger. The player is going to um, be affected by gravity, and when it touches the water, it'll apply the buoyancy force. So we'll go to the forces here and go to buoyancy. So with this buoyancy force generator, you add a water level as well as a liquid density, because buoyancy is dependent on how dense the water is. If it's like insanely dense water, then you float way more than if it's like not. An example of this is just air. Air is not dense at all, so you don't really float. But as it gets denser, e.g. Water, you start floating. Okay, so what we're gonna do is, to start things off, I'm gonna just set up the scene. Right now we have player. I'm gonna just go here. I'm gonna change the shape to be just a rect. I'll just do a circle. I'll just do a rectangle actually, just because, you know what? Actually, it doesn't really matter, but it doesn't matter. I'll just do it like that, so it's more consistent. Because the buoyancy force actually does depend on the shape of the object. That's something else. This is just like how I wrote it. But the more volume, in this case for 2D area, that's in the water, the bigger the force is. So that's something to note. Okay, so I'm gonna start by the player is a rectangle. This, instead of not ball, we'll just call it water, because we're doing a water scene. We're gonna delete the ball. That the ball itself will delete. Is this the ball? Okay, like this. And this trigger here. Okay. And we're gonna go like this. And just trying to think about this here. Okay. Step one here, we give the player gravity, so it goes downwards. So gravity.y is equal to, we'll just go 10, and we'll see what happens. Player moves down. I'm actually pressing up right now, which is why it's floating up. But yeah, it detects the trigger, but doesn't actually push the player upwards, which is expected. Okay, so you have these we're going to go and just so it's more organized, we'll just say if trigger dot object index is equal to a water, and then we're just going to go message water entered. Okay, now we'll just do the same thing here, but we'll go here, water exited. I'm sure that's how you. Okay, so we have functions. These get run when they collide with the water. So what we want to do is create the buoyancy force here. So I'm going to create the buoyancy contact generator here. This would be the, I'll just put it up here so it's more organized. We have a trigger generator here, and we now have a contact, or it's actually a force generator for buoyancy. How do you spell buoyancy here? Okay, buoyancy is equal to nu. Okay, and this buoyancy force generator requires the water stuff and everything. So what's interesting here is because the buoyancy force and the trigger itself are completely separate, I could set the water level to be anything. I could set it to 0, and it would, right when this player touches this trigger, if the water level was 0, it would be up here, and it would apply a force as if it was already underwater. Just to keep it consistent with how it looks, I'm going to just choose exactly where this is. So instead of manually doing that, actually, it'd probably be best to get the actual number. So I'm going to go and this is going to be interesting here. So I'm going to go to the player here, and I'm pretty sure it doesn't matter what I put here, but I can change the water level later, yeah, without it worrying about anything. So yeah, okay. For now, I'll just put it to be 0. And liquid density, I'm going to set it to default. Actually, I'll just see what is the default here. It probably is, okay, 0.1. So 0.1. The bigger this number is, the stronger the force, I'm pretty sure. Because we multiply, sorry, let me just go like this. Oh wait, sorry, this one. Oh yeah, so we multiply by the area. Yeah. So the bigger the area and the bigger the density, the stronger the force. Okay, fortunate for you. Okay. So we created this, and because we don't know what the water level is right now, we could change it later. That's what we're gonna do here. I'm gonna go to the room start, and when I add it to nbp add force generator self.id, and I'm gonna pass in other dot force generator buoyancy. Before or after doesn't really matter. I'm going to set water level for buoy, and on top of that, I'm gonna do it not here because the scope is in here anyways. And I'm going to just real quick set up or link generators. Okay, so set water level for buoy here. We're gonna go into so what you need is you need the trigger itself. Because it's in room start, the trigger should have already been created. So we're gonna find the water itself and we want the bounding box of the top. That's the real global location of the water. So we can, this number is going to be FG buoyancy dot level or water level is equal to that. So the buoyancy force generator's water level is now equal to the top of the bounding box of the water trigger itself, and we've linked the buoyancy force to this. So this essentially means this is completely independent of the trigger itself here, actually, just to show you that the buoyancy force will apply to it here. There you go. Okay. But let me show you actually the important thing here. Why triggers are actually it's good to use trigger. If I did this, the player has the buoyancy force applied to it right now. Let me see real quick. Actually, close this. We don't need that. We don't need any of these. Okay. So on room start, player gets a link to the buoyancy force, but the way the buoyancy force works is that it just, that's actually not what we're looking for here. We're looking for this one. Okay. It just straight up uses a y value. If you're below that y value, a force is applied to you. So what if the water, for example, is like this, right? And you're right here. The water should not apply to you, the buoyancy force. Yet it does, because that's how the buoyancy force generator works. So what you would instead want to do is only add this force generator when you touch the trigger itself, and then you remove that force generator when you leave the trigger. So you can have multiple buoyancy forces applied to this object as they go through a level, for example. So let's do that. Step one is to remove this. Whoops. Actually, we can just get this one here. And we created it here, it's fine, but we don't link it until, actually, just to do it, we don't link it until OnTriggerEnter. So when you touch the water force generator here, you're going to add a force generator to the player. In this case, we're passing in the regular force generator here. And yeah, this should work, but we don't have anything for on-trigger exit. But for now, I'm just going to just see what happens here. So the player passes through, touches this, boom. Okay, cool. Let's change the water density. We're trying to 0.1. That's kind of, actually, no, we'll keep it the same. Or do we keep it the same? Yeah, we keep it different because we're gonna have to test exiting out. Okay. So as you can see, the force generator is applied to it, but now when I go here, it's still applied to it. So that's where we do the on trigger exit stuff. So now we can go and very easily nbp remove trigger, or it's actually force generator self.id fg. I'm not gonna spell this because it's kind of, there you go. All right. So this is actually how I did it in the platformer demo, which is why I didn't see the custom force bug, because yeah, there you go. Okay, yeah, so that's how you can remove and add force generators in an on-trigger enter and exit like function. So yeah, that's I think it for that's it for this video, I think. Yeah, there's nothing else really to say. Yeah, in the future, I'm going to be just focusing on making stuff with this engine and just showcasing some of the things that you could do with it. One of the things I have an idea for is like making different aggregate bodies of like physics objects. Like for example, like a rope bridge or a pendulum or something. So yeah, stay tuned for that. And of course, I'm gonna just maybe also show different demo video game ideas for like how to do a platformer with this or how to do things like that. So yeah, if you're interested in that kind of stuff, uh, subscribe, and I'll see you in the next one. Thank you. Bye.